Hello, this is Mrs. Huntley. We are in Module 4, Lesson 22, Constant Rates Revisited. You should be on page 96 of your module. And your essential question for this lesson is, when I am writing an equation for a constant rate problem, how do I know which situation has a greater or lesser constant rate of change, or greater or lesser rate of change? So first of all, what is our definition of constant rate? This is going back to earlier in the module. I think it was actually in the last book. Constant rate is the average rate over an extended period of time. Synonyms that mean the same thing as constant rate are slope, rate of change, and constant of proportionality. Constant of proportionality, I think, is something that you guys talked extensively about last year in 7th grade when you were learning about proportions. And that is the same thing as slope in an equation. It's the same thing as rate of change when we're talking about a table. So let's take a look at some story problems here. Erica set her stopwatch to 0 and switched it on at the beginning of her walk. She walks at a constant rate of 3 miles per hour. So if I'm writing that again, x will, excuse me, y is our distance, x is our time. We always write as distance over time. So our constant rate is going to be 3 over 1. In our table, it says express this as an equation, a table of values, and a graph. So remember yesterday when we did our, or earlier this week when we did our matching activity? Equations, tables, and graphs, same information, different way of looking at it. So here's our time, this is our distance. If I'm using, again, I said the constant rate of change is the same thing as slope, right? So if I'm writing this in an equation, it's going to be y total distance equals our constant rate times the time that we are walking. Let's see if this all works out. So when we're not walking at all, when we haven't started walking, 0 time, we've gone 0 distance. It says 1 hour, we're going to be going 3 miles. In 2 hours, we're going to be going 6 miles. In 3 hours, we're going to be going 9 miles. We could plug all of those values into the equation, but hopefully the math is so easy that you're not requiring me to do that, because again, it says in 1 hour, she's going 3 miles here in the problem. So that one I didn't even have to do any math for. Hopefully you recognize that in 2 hours we'd be doing 3 times 2, and that's going to equal 6. 3 times 3 equals 9. So if I'm graphing this information,
Mr. Mate, please call the office. Mr. Mate.
0, 0 is right in the center there. 1, 3, so come to the right 1, up 3. 2, 6, come to the right 2, and then up to 6. And 3, 9. It's a straight line, so we can connect up those points. And this arrow will keep going. The more she or the more time she walks, the farther she's going to be going. Now let's take a look at our equation really quick. What is the meaning of the 3 in this equation? It's the slope, yes, but it's also the rate that Erica is walking. So the rate or the rate of change, the constant of proportionality, those are all the same thing. And I want you to be able to recognize it both in an equation, when you're figuring out a slope off of a graph, like if you were calculating the slope here, your rise is 3, your run is 1, so it's going to be a 3 over 1. That's going to be the rate that she's walking, 3 miles in 1 hour. Let's take a look at example 2. Okay, a faucet leaks at a constant rate of 7 gallons per hour. So our constant rate here is going to be 7 over 1, 7 gallons in 1 hour. Express the situation as a linear equation in 2 variables. y, we'll let y equal the total amount leaked, and x is your time. We should always identify our variables. I almost jumped right to the equation here. So y, the total amount leaked, is equal to the amount that's leaking, 7, times the number of hours. We could say 7 over 1, but 7 over 1 is the same thing as 7. So the slope represents the rate at which the faucet is leaking. It's your constant rate. Another faucet leaks at a constant rate, and the table below shows the number of gallons Y that leak in X hours. Oh, golly. Hang on a second here. They flipped. No, they didn't. Okay, I'm just looking at it weird. Sorry. So this is our time, and this is the number of gallons. So we can attack this problem one of two ways. Remember, we were doing change in y over change in x. So if I figure out the change between here and here, we're looking at 13 to 26. That's a plus 13. 2 to 4, that's going to be a plus 2. Change in y over change in x, that's going to be 13 over 2. That's going to be 6.5. Okay, another way that we can attack it, you know what, actually you might be looking at this and going, wait a minute, the next one, 26 going to 45, that's not at the same constant rate. That's actually going up, what, 19.5 here. But if you look at the other side, this side is going up by 3. So it is actually a constant rate, because if we do 19.5 divided by 3, we're still going to get 6.5 as our constant rate. Now, if you're one of those people that you're like, okay, that makes no sense to me, Mrs. Huntley, I want to do it the other way that we talked about, fine. Do a slope L. You've got points here, 2 and 13, 4 and 26. Subtract down. 13 minus 26 is a negative 13. 2 minus 4 is a negative 2. Negative 13 divided by negative 2, again, is 6.5. So we're going to come out with the same rate. It doesn't matter which strategy you use to attack the problem. Some of you might be saying, couldn't I have just taken this one, 13, and divided by 2 to figure out the number leaked per hour? Yeah, you could have. That would have been fine too. So from writing this equation in two variables, y, again, is my total amount leaked, is equal to 6.5, that's the amount leaked in 1 hour, times x, the number of hours that the faucet is leaking. So looking at these two scenarios, which one is leaking at a greater rate? Which one is going to have the most water wasted after the same number of hours? If we look at our rate at which they're leaking, hopefully you're recognizing that 7 is a greater number than 6. So the first faucet is leaking at a faster rate. If something is leaking at a faster rate, it has a larger number representing the slope, or the constant rate of change, or the constant of proportionality. Again, those three ways of saying things, saying exactly the same thing using different words. Let's take a look at another example here. We've got some trains. The graph below represents the constant rate at which train A travels. So train A, in 1 hour, travels 60 miles. So our distance over our time, 60 over 1. If I'm writing this in an equation in two variables, I would say y is going to be my total distance. So y is total distance. X is amount of time traveled. So total distance is equal to the constant rate, 60, times the number of hours traveled. Okay, train B travels at a constant rate, travels at an average rate of 95 every 1.5 hours. So 95 over 1.5. So I'm going to actually do this math here since we don't have a table and we don't have any other information. So 95 divided by 1.5, we're looking at about 63.3 repeating miles per hour. So when you're writing this equation, we're going to define our variables exactly the same way. So y is your total distance, x is your time traveled. So y is going to be equal to 63.3 repeating x, or if you want to leave it as a fraction, it would be y is equal to 95 divided by 1.5x. Comparing the two, which train is traveling at a greater rate of speed? Hopefully you're recognizing train B has a higher rate of change, which is slope, which means it's traveling at a faster rate of speed. Which strategy of comparing each rate of change allows us to determine which train is traveling at a faster rate? The slope represents the constant rate in a specific time interval. If the time interval is the same, whichever is greater will be faster. So our time interval needs to be the same in order to compare our slopes and make sure that it makes sense, that we're comparing our apples to our apples, etc. All right, let's do one more example together. So page 99. The graph below represents the constant rate at which Christina can paint. So Christina can paint, oops, this is our feet. She can paint 4 feet in 1 hour. So our slope here, rise over run, 4 over 1. So if I'm writing an equation, it's going to be y equals 4x. Again, it could be plus 0 because at 0 time she's not going to have anything painted. And of course you could have it as 4 over 1. Christina's sister Tracy can paint at an average rate of 45 square feet in 12 minutes. Oh, you know what? I said per hour. This is actually in minutes. I was just thinking, oh, I've got to do a conversion there. I did it wrong. But it's not. This is time in minutes. So she can paint, Christina paints 4 feet in 1 minute. So Tracy paints 45 feet in 12 minutes. Go ahead and set that up. So remember, whatever she's doing over the time. So we're going to have 45 feet over 12 minutes. Do the division to find out how many feet she does in 1 minute. So 45 divided by 12 is going to be 3.75 feet in 1 minute. So if I've got this equation, I'll have y equals 3.75x. So who paints faster here? Who paints faster? Wow, I can speak, just not well. Who paints faster? So Christina paints faster. She can paint 4 feet per minute. Tracy only paints 3.75 feet per minute. And I don't know why this turned out to be so big, but we'll make it smaller because I'm not shouting it at you. So Christina paints faster. How does the slope provide information? We need to answer the question about which sister paints faster. The slope is the constant rate. In 7th grade, you learned it as the constant of proportionality. This year, we're learning it as slope, constant rate, constant proportionality. They all mean exactly the same thing. The other examples, actually, why don't you pause the video right now and see if you can do example 5, and then unpause the video and see how you did. So please go ahead and pause the video. It's about two companies. We've got a graph, and then we've got some words, Figure out the constant proportionality and compare the slopes. Higher slope would be more energy per hour. Okay, so for the first scenario, 120 per hour, so y equals 120x. Company B offers a solar panel that produces energy at an average rate of 325 watts in 2.5 hours or 2.6 hours. Do the division and you get 1.25 and 1. So y equals 1.25x. Which company produces the most? Compare the slopes. The slope represents the constant rate of change. If you are looking for which one produces at a greater rate, you want the greater slope. FYI, read the problem carefully. If you're looking for a situation that costs less money or changes more slowly, you might be looking for the smallest slope, but just recognize that the slope is representing the rate of change. The higher the slope, the greater the rate of change. We're going to end the lesson here. We are going to do the rest of the work in class. So again, if you have any questions, make sure you've made a note of them and make sure that you bring them to class with you. Have a good night.